Hello, hello? Okay. That sounds right. Okay, we'll start again. So I want to review a little bit of the probability material we went over last time. As I said, probability system is a mathematical model of real-world experiments. Consists of a sample space, a set of events, and a probability measure. Definition of mutually exclusive events. See, there's an S missing here. If the union of all the events is the full sample space and the intersection is 0, the null space for each, then that set is a set of mutually exclusive exhaustive events, and we'll be using quite a few of those. Conditional probability, right here. Statistical independence, right here. Important theorem, right here. This is the fundamental theorem of probability theory. It says you want the probability of event B. You can find it by conditioning it on an event A, multiplying the probability of that event, summing over all possible events, a set of mutually exclusive events, and you'll be able to find P of B. And we'll see this perhaps even today. This is a very powerful idea. I mentioned this to you before. Sometimes the probability of event B is hard to calculate. But if you knew something else, like in this case the event AI, it simplifies it greatly. Once you get that, you make the sum and you got the answer. So it looks like it's complicating it further, but each term is simpler and you sum and you're done. Bayes' theorem, the whole idea is that instead of going for A given B, you can go on B given A. It reverses your focus. It's a comfortable theorem. Talked about a random variable. It has a probability distribution function, a probability density function. Distribution function, just simply the probability that the random variable cap x is less than or equal to the number little x, less than or equal to little x. We defined the unit step function as this thing, a very simple function, and its derivative, which is the unit impulse function. And there's others as well. You can go one more, basically integrate that once more. U minus 1, you'll get that linear function. U minus 2, you'll get the parabola, etc. There's a whole family of these. And they're given by this expression. It's in your tables. We went through expectation. Defined expectation is simply for density. It's x times the density of the x to get the mean or the average value or the expectation of that random variable. And nicely, if we have a function of a random variable, y is a function of a random variable x, g of x, then to find its expectation, you don't have to find the density on y. You can do it by taking the expectation with respect to x, whose density you know, it's given right here, times g of x is the multiplier. So this is very handy. It simplifies calculations. We went through the simple calculation also that if you have two random variables, you sum them. The expectation of the sum is always the sum of the expectations, independent or not. However, the expectation of the product is the product of the expectations if they're independent. And if not, it's not. And I'm going to show you the difference later. But for the next assignment you're going to have, it's going to